Hello and welcome to GoFormative number 46. This lesson is about point slope form. Point slope form. This is an AGS 1 lesson. So if you're listening to this and you're going to take AGS 1 next year as an 8th grader, they do a lot of point slope form. And I'm just going to write that here. Point slope. You guys are currently used to this, y equals mx plus b, and as a reminder, we can take y equals mx plus b, and we can plot a line from there. If you tell me that the equation is y equals 2x minus 1, I know that the minus 1 goes here, and then I'm going up to over 1, and my point is here. And that's my line. And that's important for you to know as a reminder. The point slope lesson is the same stuff, but they're asking for you to rewrite the equation in a different way. So if you look carefully, there's the point slope formula. So I'll put them kind of side by side and let you look at them. That's brutal. It's going to bug me. Okay, here we go. So yours is y equals mx plus b. Okay, and the new one is y minus b equals m, and then times x minus a. It's just a different way of writing the same thing. You can actually see, if you look carefully, there's the y, it's got the same parts. Watch this, if I subtract b on both sides, just because I wanted to move it over, watch. Wouldn't I have y minus b? Well, that's what I got right there. And if I did that, I would have mx, right? And so what they're doing is they're basically having the same equation, just rewritten, okay? So as far as new material, the only new thing is the equation itself. You've already learned the skill, you've already learned how to graph it, you've already learned how to plot, you already know how to do that. So now it's just a matter of making sense of the new equation. And where do we put the numbers in the right spots? Okay, so let's go to this next one. I'm looking right here. Copy the following below, okay? AB is the same as x comma y. So that'd be important for you to know when you're looking at your new formula, x comma y, and a comma b they're the same. They're coordinates that you would find on that line, okay? So let's take you back to this. And let's make up an equation, y equals 3x plus 2. If I were to graph y equals 3x plus 2, right? A little bit lower, so I got some room. I would have to start at 2 on the y-axis, and I would go up 3 over 1, and that would be my line. And I want you to think about the points on that line. Like, what is that point right there? What is this point right there? What are those points? This one is 0, 2. and this other one is 1, 5. Obviously, these points are on that line, right? Because we can see it. It's on there. So how do you prove they're on there? You can plug them in. If x comma y is the same as 0 comma 2, and the equation is y equals 3x plus 2, I can substitute 0 in for x and 2 in for y. And it would look like this. 2 equals 3 times 0 plus 2. And all I've done is insert the actual coordinate. There's my x, there's my y. And if the statement is true, then 0 comma 2 does fit in that equation on that line. So 3 times 0 is 0. So I end up with 2 equals 2. It's a true statement. Okay, let's check the same equation except for instead of 0 comma 2, let's try 1 comma 5. And 1 comma 5 would look like this. There's my x coordinate. There's my y coordinate. It doesn't make a true statement. 3 times 1 is 3, plus 2 is 5. I would have 5 equals 5. That makes a true statement. That means that 1 comma 5 is on the line y equals 3x plus 2. Then I can make up another point, right? Let's make up a point. 10 comma 6. 10 comma 6. Is 10 comma 6 on that line? All you have to do is plug in for the x and plug in for the y, okay, and find out for yourself. So that's all you have to do is plug it in. So it would be 6 equals 3 times 10 plus 2. Notice that the y value went where the y was and the x value went where the x was. 3 times 10 is 30. 30 plus 2 is 32. And the last time I checked, 6 is definitely not 32. So what that means is, what about 10 comma 6? Is 10 comma 6 on this line? No, it's not. It's not on that line. Okay. Should we make up another one? Let's try 2 comma 8. 2 comma 8 on y equals 3x plus 2. Let's plug it in. Remember, this is x, this is y. So we're going to rewrite it as 8 equals 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 equals 8. Let's see. So we have 8 equals 8. That works. So what do we know about this coordinate 2 comma 8? What do we know? That it's on that line. Okay. We can do that with any coordinate. We can just plug in coordinates for days, and I think that's the missing link. Okay. From the students who have me and learn how to graph, and then they leave me and go to AGS 1, and all of a sudden the teacher's expecting to know point slope. The disconnect is that my students don't know how to plug in coordinates to see if the coordinates are on the line. If you knew how to plug in coordinates, then point slope would make a lot more sense. So, for the sake of that argument, can we do a couple more? Y equals 1/2 x minus 1. So step 1 would be, can you graph that? Okay, let's see. Minus 1, and then you go up 1 over 2, and then you have your graph. Okay. And then what's this coordinate here and what's that coordinate there? So we have 0 comma negative 1, and we have 2 comma 0. both those coordinates are on that line. So when I plug those coordinates into the equation for y and x, that both sides should equal each other and it should work out. So let's test both of those first to make sure that we didn't do it wrong. So I'll just do them side by side so we can see both of those. So -1 equals 1/2 times 0 minus 1. And then we have 0 equals 1/2 times 2 minus 1. And then we solve both those. So let's do this part first on each of these. Order of operations, when I do the subtraction first. Or I'm sorry, the multiplication first. So 1/2 times 0 is just 0. And 0 minus 1 is -1. So that's a true statement. 1/2 times 2 is 2/2, or just 1. And 1 minus 1 is 0. So we have another true statement. So here's what we know. We've proven that both these coordinates are on that line. So let's make up another coordinate and see if it's on that line. Okay. 6, 1. Is 6, 1 on this line? And remember, this is the x and that's the y. So we're going to plug in for y. 1 equals 1/2 times 6 minus 1. And we're going to solve. So we're going to start with this times part here, multiplication. What is 1/2 of 6? 3. What's 3 take away 1? It's 2. So is that a true statement? No. So what do you know about 6, 1? It's not on that line. Let's try 5, 1. It'll look like this. 1 equals 1/2 times 5 minus 1. So what's 1/2 of 5? It's like 2.5, right? And what's 2.5 take away 1? 1.5. So is that a true statement? No. No, it's not. Let's try 4, 1. It'll look like this. Start with this. What's 1/2 of 4? 2. What's 2 minus 1? 1. Is that a true statement? Yes. So what do we know about 4, 1? 4, 1 is on that line. Let's find out. Where's 4, 1? It's right here. That's 4, 1. So it is on that line. So that's how we do that. And we just need some practice plugging in coordinates to see if it's on the line. Okay. So let's do something random where we're not graphing. Okay. This is how we kind of separate ourselves from, okay, I've learned the first step. Now I'm ready for the next step. If you can't do the next step, just rewatch the video and work yourself back up to this opportunity. Okay. So we're going to take something like y equals 2x plus 3, and we're going to make up a coordinate, 100, 90. Okay, so what do you have to know? You have to know which one's the x and which one's the y. X, y, that's what you have to know. Then you have to be able to plug those in. So the x will match, and then my y's will match. So I'm going to rewrite this problem as 90 equals 2 times 100 plus 3. And I get 90 equals 200 plus 3. What's 200 plus 3? 203. So is 90 the same as 203? No, of course not. So what did you learn about this coordinate? Is that it's not on that line, right? Let's pick another coordinate, okay? Let's pick, one, let's just go with 180, comma, 183. And the equation is y equals 2x plus 3. How would you do it? You have to know that that's the x and that's the y. You have to know that the y's are going to go together. You got to plug those in, and the x's are going to go together. So 183 equals 2 times 180 plus 3. So that's 360 plus 3 equals 183. That's like 183 equals 363. So what do you know about that coordinate? It's not on that line. Okay. How many more should we do? Well, it's not about how many more should we do. It's, do you know how to plug these in the right variables? Do you know which one's x and which one's y? Do you know how to plug them in? It doesn't even matter if the calculator does the work. It's okay. But you need to be able to figure, do I know how to plug them in? Do I know how to plug in coordinates to see if it's on the line? That's what we want. Okay. All right, now let's try the magic number here. 90, comma 183. All right. So in order to do that, again, one more time, it's y equals 2x plus 3. And you have to know which one's x and which one's y. Okay. And plug them in. So we have 183 on the end. We have 2 times 90 here plus 3. So what's 2 times 90? It's 180. And what's 180 plus 3? It's 183. Imagine that. So, does that work? Yes. What does that mean for this coordinate? What's it mean? I'm going to keep shading it until you tell me what it means. Okay. So, it means it's on that line. If we had a big enough graph and we graphed every point we could on the graph forever, for infinity, then that point, 90, 183, would be on this line that goes on forever. The reason why this is hard for us is because we've only worked with graphing in a limited space, right? So 4, 5, and if something was 10, 12, we'd be like, whoa, I'm out of room, right? That's what we're used to. We run out of room. So it's hard for us to imagine, okay, we're going to go over 90 to the right, and then we're going to go up 183, and we're going to count each of those, and then we're going to plot that line. Like, that's hard for us to imagine. So this needs to be something where we look at it now and say, okay, give me any coordinate, give me any equation, and I can tell you if it's on that line or not. That's where we need to get to. Okay. Maybe last one. Right. Y equals x plus 5. And here's your coordinate. I'll give you 2 of them, and the only secret I'll tell you is that one of them will work. And you got to figure out which one that works. Is it going to be A that works, or is it going to be B that works? Dun, dun, dun. Okay? All right, so the x coordinate is going to be 100 on both. Okay? But the y coordinate is going to be 104 and 105. So how do we know if it's going to work? We have to plug it in. We're going to plug in 100 for the x, and then we're going to plug in 104, oh yikes, 104 for the y, and then 105 for the y, and see which one works out. And if you're sitting there right now and you're still watching this video, number one, I apologize that you're still watching this video. But number two, you might have already solved this problem. You might be sitting right now going, oh, I know which one works. If that's you, then congratulations, you've kind of figured out how this works. You know how to plug things in. And so let's plug each one in. This one's 104 equals 100 plus 5. And this one's 105 equals 100 plus 5. Now, this one is going to be equal to 105, and that's not true. And this one is equal to 105, and that's true. And so you know that this one, B, is on that line. Okay. All right. A little faster. Okay. Kind of did some walkthroughs. We're really good at walkthroughs. Now let's go. We got 1/2 equals 1/4 x plus 9. And the coordinate, and I'll just give you 1, okay, is 24. Okay, 24, 15. All right, how do you do it? That's the x, that's the y. Plug it in, see if it works. You have 15 equals 1/4 times 24 plus 9. Well, do this part first. What's 1/4 times 24? And you can do, there's a couple ways to do that, right? You can do 1 times 24 and then divide it by 4, or you can just do 24 divided by 4. Either way, we want to take 24 and cut it in 4s, okay? The answer is 6. Then we have 6 plus 9. We got to be able to do that. That equals 15. So what do we know about our coordinate? It's on that line. That's right. Okay, here we go. Y equals negative 2x plus 3. And we're going to throw in, 50. 50 as your x, comma, 40. X, y. So 50 is going to go in here, and 40 is going in there. So 40 equals negative 2 times 50 plus 3. Negative 2 times 50, that's negative 100. And negative 100 plus 3 is negative 97. And what do you think about 40 equaling negative 97? That doesn't work. So you do a little slash, and what does it mean for the coordinate here? It means it doesn't work. It's not on that line. Okay, let's try another one with y equals negative 2x plus 3. Well, let's just use 50 again. Okay, except for we're going to make the other one negative 97. See what I did there? Let's find out. So that's going to go there, and that's going to go there. Negative 97 equals negative 2 times 50 plus 3. So negative 100 plus 3 again. Except this time, guess what? It equals negative 97. So what do you know about that coordinate? It is on that line. Okay, I think I've exhausted it. Plug and play and figure that out. Now we can kind of continue with our lesson on point slope. So let's just go over here now. I gave you some instruction here. It says AB is the same as XY. And then this question says, A and X are the same thing. So we need to look up here. You see where A is, it's first, see X, it's first. Yes, they're the same thing. And same with B and Y. B and Y are the same thing. So true on both those. Write the equation for point slope. Oh, I forgot it. I don't know it. Okay, there it is. Y minus B equals M times the quantity of X minus A. Okay, it's perfect and it's beautiful. Thank you. This one, regarding the point 3, 5, 3 is the X and 5 is the Y, true or false? And this is again testing, do you know which one's X and Y? That's super important. This keeps coming up. X is first on that. Regarding the point -2, 3. -2 is the X and 3 is the Y. Regarding this point, 10 is the X. No, it's not. Regarding this point, regarding this point, regarding this point, regarding... Write this point slope form again. Okay, let's see if we can do it from memory this time. Y minus B equals M times the quantity of X minus A. And we can just look back right here. I just wrote it. So yeah, yay. If you do it enough times, you won't have to look anymore, right? I always tell my students, I want you to know this math like you know your first name. When someone says, hey, how are you? What's your name? You don't go, my name is Smithers. You don't, okay, your name's not Smithers, okay? But you definitely will be looked at kind of interestingly if they're like, you don't know your own name. So that's how good I want you to get with the math. And if you do it over and over and over and over and over and over, you have very, very good potential to commit it to memory or commit it to something that you know, something that you can use. Okay, you will use this in 8th grade, 100%. Use the point slope, use the point 42 as AB with the slope 3 and write the point slope formula with those numbers in. So it's asking you to write this formula, but with 3 numbers in it. 3 as the slope, which is M, 4 as the X right there, right? And then 2 as your Y. That's what it wants you to do. But it wants you to use A, B instead of the X and Y. So let's leave the X and Y as is and just plug in those numbers. Okay, here we go. First and foremost, I'm going to write the equation again because you can never get enough. Like when you're annoyed doing math is when you almost have it. Okay, so keep going. So they've asked us to do 4, 2 as A, B. So instead of A, I'm going to write 4. And instead of B, I'm going to write 2. And then instead of my slope, M, I'm going to write 3. Okay? How did I do it following directions? I've got my 3 for the slope. I've got my 4 for A, like they told me, and I've got my 2 for B, like they told me, and I didn't touch the negative signs, just kept them the same. And that's all that problem asks you to do, by the way. There's nothing to solve there. You can leave it, okay? It's when you get to here that you need to solve. Was this your answer? And it's still, we're not solving, but it's like, does that match? Yes or no? I think it matches, also because it says yes. Use the point 1, 2 as AB with the slope of -4. So we have Y minus B equals M times the quantity of X minus A. And this time we're going to have Y minus 2 equals -4 times X minus 1. And then is this match? Looks good. And more of the same, more of the same. I'll let you do that one on your own. I just did 2 of them. What's wrong with so they must have got it wrong. Something must have happened. Oops. So better pay attention to that. Write the equation for point slope one more time. Okay. Anybody know it from memory yet? If you're still listening to this, can you do it from memory? Right. Can you close your eyes and do that and be like, y minus b equals m times the quantity of x minus a? Okay. Look at the three types of equations below. Let's look. Standard form, y-intercept form, point slope form. Ax plus by equals c, y equals mx plus b, and everyone's favorite. Okay, why did I write those down? Because I got a feeling they're going to ask me to write them down. List the three names and three formulas we use for graphing. So now you're literally going to have to put this in and then put them with names. Okay, so point slope and y-intercept and standard form. And again, 22 is just asking you about 21. Okay, now this is just an introduction for point slope. And there will be a follow-up to this lesson. And it will be part 2 for why we need to know point slope. And it'll be the 51st GoFormative that I make for this section. And look for that. And when that's made, it's going to follow up on this lesson. This lesson was all about, do you know or remember this? And can we just restructure what you know here? And that's what this lesson was about. Thanks for watching.